What's up? What's up? All you crazy mathematicians out there. Welcome to solving equations with the variable on both sides. So, we're going to be solving equations, but now they're going to look a little bit different. So, if you notice here, I have two different x values. I have my x on terms with x in it, I should say. I have a term with x in it here on the left-hand side of my equal sign, and I have a term with x in it on the right side of my equal sign. This is what we mean by solving an equation with a variable on both sides. We're talking about both sides of the equal sign. So they look like they could be complicated at first, but really it's just one extra simple step, and then it should look very similar to a two-step equation or something that we're familiar with solving. So step one is to get rid of any parentheses if necessary. So for today's purposes, we're actually not going to have any parentheses in this video. I'll have another one with that later on. But that's when we would do distributive property or get rid of the parentheses. But that's when we see equations with that on the variable on both sides, you will need to get rid of parentheses first. Then step two, after we get rid of all of our parentheses, this is when we move the variable to one side of the equal sign by using addition or subtraction. Okay, and I'm going to show what that means or what that looks like in just a second. Okay, so we want to move the variable to one side of the equal sign by using addition or subtraction. And then finally, we're going to solve like a normal equation. So the big thing here is really step two is really what step two is really the big piece right here. Okay, this is really the big new thing that we're learning today. So here's that same equation that was there before. So what we're going to do is there's no parentheses to get rid of. So I need to move my variable to one side of the equal sign by either addition or subtraction. And here's the cool thing about when the variable is on both sides of the equal sign is it doesn't matter which one we choose to move. Okay, so what we're going to do is it's almost like combining like terms, but we still have to do the inverse to cancel things out and do it on both sides of the equal sign. So here's what I mean by that. What I can do is this is just x. Whenever we have just an x, there is that imaginary 1 in front of it. That's the same thing as 1x. So I'm going to put that 1 there now just for the purposes of this video. What I can do is I can decide to move this 1x over to the right side or this 3x over to the left side. The way we do it, though, is we have to cancel it out. So if I wanted to move this 1x over here, what I need to do is I need to cancel out 1x. But now I'm trying to cancel out the whole term. So before, when we say I had 2x equals 6, okay, we were solving these one-step equations. Before, we were just trying to cancel out the 2 to get x by itself, so we divided by 2. Because that was our way of solving this equation in order to get x by itself. But now I'm not trying to get rid of just the 2, I'm also trying to get rid of the x as well. So I'm trying to get rid of all of 2x. So because I'm trying to get rid of this entire term, I'm actually going to do something different. I'm not going to do any division. Okay, so if I wanted to get rid of this whole term, I could subtract the entire term because 2x minus 2x is 0. So I'm taking something and I'm subtracting it from itself. So that's going to cancel out. And so that's what we're going to do over here. So here's what I mean by this. Okay, I just made that part up. If that confused you, I apologize. That was me just making up something to show you an example of what I was talking about. So I want to get rid of the 1x right here. I want to move this over to the right side so I only have the variable on one side of my equal sign. So because this is a whole term and I want to get rid of the x, and this is a positive 1x, I would do the opposite, which is subtract 1x. Because 1x minus itself, any number minus itself. If I take 5 minus 5, that's 0. If I take 2 minus 2, that's 0. If I take x minus x, that's 0. If I take 4x minus 4x, I'm taking any number and subtracting it from itself. It's always going to be 0. Now, we don't know what x is, but it doesn't matter because it's the same thing here and here. So now what I do is I'm going to subtract 1x from the left-hand side. That cancels it out. That makes it go away. That equals 0. We like 0 because it makes things go away. But the same rules still apply. Whatever I do on one side of my equal sign, I have to do on the other side of my equal sign. So I'm also going to subtract 1x from this 3x right here. Now, the reason why I can't subtract this 1x from 1 is because these are not like terms. I cannot subtract an x from a constant right here that doesn't have x. You can only subtract your x's from x's or your same variables from each other, and you can only subtract or to add your constants with each other. So I subtracted 1x, that goes away. I still follow all my other steps. I bring down my 5. I still have my equal sign. 3x minus 1x is 2x, because now the x's just follow along. It's just really 3 minus 1 is 2. And then I have to bring down this minus 1 because we haven't done anything with that yet. And if you look, now I have a normal two-step equation. Okay, so we brought the variable from one side to the other, and now I have a normal two-step equation. Because now the cool part is what I can do is I can get rid of this minus 1 by adding 1 to both sides, just like what we did for two-step. This is 6, bring down my equal sign, bring down my 2x. Oh, that's ironic. I didn't even mean to do that when I made up my 2x equals 6 earlier. So now I'm dividing by 2 to cancel out the multiplication, because now my goal is to get x by itself. So this is why I'm dividing by 2, because I want to get rid of the 2 and not get rid of the x. And I get x equals 3. Now, one thing I wanted to look at though, so this one we moved the 1x over to this side. Well, we also could have moved this 3x over to the left side, and we still would have gotten x equals 3 as my answer. So I'm going to write x equals 3 over here, because that's what we just got. But then I'm going to solve it the other way just to show you that it doesn't matter which way we move the variable, and we'll get the same answer each time. So if I had chosen to move this 3x over to the left side, I would then want to cancel it out. So because this is a positive 3x, I don't see a negative sign, I have to subtract it. Because 3x minus 3x is 0. And whatever I do on one side, I have to do on the other side. This cancels. I bring down my negative 1. That's still there, or this minus 1, equals. And then I need to do 1x minus 3x. This is negative 2x. And then the plus 5 is still here. Now the reason why I decided to move this x over to this side originally, because I could tell that this was the smaller number and this was positive over here. So I did a quick little mental math in my head, and I said, you know what? I know if I subtract x from both sides, I'm still going to have a positive variable. And I like having positive numbers. It makes life a little bit easier. Now, I can solve my two-step equation by subtracting 5 from both sides. I get negative 6 equals negative 2x. Now I got to get rid of my negative 2, so I have to divide by negative 2 on both sides. That cancels, and I get x equals negative divided by negative is always positive, but I still get x equals 3. So same answer, but this one dealt with negatives, so which is why sometimes we want to look to see which one's going to keep our variable or our coefficient of our variable positive. If we can do quick mental math and figure out which one's going to be easier to move, that makes our life a little bit easier. So let's look at another one. So here I have 9x plus 3 equals 7x plus 19. So again, if you want to try it on your own, try it on your own. Pause the video, give it a shot, and then check to see how you did. That's only going to help you out, and then you can see if you get it or not. Okay? But so what I want to do first is I want to do a quick mental check and figure out, well, which one should I move over? Should I move the 9x over to this side by subtracting 9x, or should I move the 7x over to this side by subtracting 7x? I know I want to move one of them over to either side, and the way I do it is by subtracting, because these are both positive. What I'm looking at here is if I move this 7x over to the left-hand side, 9 minus 7 is going to be a positive number. So that's the one I want to do, because I like to have positive numbers. I like to keep things positive. So 7x minus 7x is 0, so I'm also going to do it on the left-hand side. That cancels. Bring down my 19 equals 3 plus 2x. Good news is here is now I have a normal two-step equation. I got rid of my variable on one side of the equal sign, just moves it over to the other side. Now I can solve my two-step equation like normal. Get rid of my addition and subtraction first. Bring down my variable. Divide by 2 on both sides, and I get x equals 8. Okay? All right. One last one that I want you to try out, just to see, get in the habit here. So definitely try this one on your own before you watch me do it, okay? Please pause and try this one on your own. So again, I'm going to look at it. Which one should I move over? Should I move over the 6m to the right or the 8m to the left? If I subtract 8m from both sides, this is going to give me a negative 2 because I'm starting off with 6 and I'm subtracting 8. So again, most of the time you're really just going to want to move your smaller number, because that's going to make your life most of the time easier, because if I subtract 6m, I have 2m minus 11 on the right-hand side equals, and then this is just a positive 3 because my 6m's canceled out. And again, now from here, we can just add 11 to both sides. I get 14 equals 2m. This is multiplication, so I can divide by 2, and I get m equals 7. Now, one last thing you're going to see, you will see word problems. Okay. Now, the word problems is we're going to talk about what some solutions are. What some key terms are here to help us out. But word problems, we're going to have word problems with the variable is going to end up being on both sides of the equal sign. So let's look at this one. So we have Andy's rental car company charges an initial fee of $20 plus an additional $30 a day. So I'm just going to write that down right now. I'm going to put A for Andy. Andy charges an initial fee of $20. So we have our $20 initial fee plus, there's that word plus right there, an additional $30 a day. We don't know how many days. How many is $30 a day? It's $30 times however many days they have the car. So there's Andy's. Buddy charges an initial fee of $36. Or maybe you don't want, how about this? Initial fee of $36. Bam. Let me write it in blue just so we can color code here. So initial fee of $36 plus an additional $28 per day. So this is $28 per day. Okay. What we want to know is what number of days is the total cost for both companies equal. So I have my equation for Andy. I have my expression for Andy's, and I have my expression for Buddy. I want to know when the days for this amount for this company and the days for this company are equal. So again, because I have D for days over here, and that's what the variable is, I just want to know when they're equal. So I just put an equal sign in between the two. So now I have an equation of 20 plus 30D equals 36 plus 28D. And now I can just solve my equation like we did before. Okay, oh, and that gives me, almost forgot, time for a joke. So, here's the joke for the day. Why should you never talk to pi? So why should you never talk to pi? Because they'll go on and on forever and ever. You get it? They never stop talking because they go on forever. It's great. Okay. Moving on though. Now I want you guys to solve this equation if you haven't done so already. Pause it, solve it. This will be your last check, and then we'll see how you did. I'm deciding to subtract 28D from both sides. And the reason why I went with the 28D, because again, that's the smaller of the two. That goes away. This leaves me with 2D equals 36, and then this 20 is still here, and this is a positive, so I got to make sure it's positive. And then I ran out of space, but we'll make this work. Subtract 20 from both sides to get rid of this positive 20. I'm left with 2D equals 16. And so then I would divide both sides by 2, and D equals 8, because 2 times 8 equals 16. So that means that for 8 days, if I rented a car from Andy's rental car company for 8 days, it would be the same price as renting a car from Buddy's rental car company for 8 days as well. That's when they're equivalent. And then after that, I'm assuming it looks like after 8 days, Andy's rental car company is going to be more expensive because they charge more per day. So after those 8 days, then this is going to be more expensive than this company. Okay? All right, guys. Hopefully this video helped. Hopefully we got some stuff down. Get some practice in. Please don't hesitate to ask me questions. And good.